Hello, everyone. Tom Twyman. I work for Docker. However, I'm a poser. I'm not actually a developer. So you can ask me questions, and I may not know the answer, but I know a lot about Docker and a lot about containers. And today's session is really all about, I kind of like to think of it as the art of what's possible with containers for local development. How many of you have used Docker Desktop? Nice. Okay, so we'll see if I'm able to show you anything new. Maybe not. Maybe, but maybe not. We're going to start just with a little bit of setting the context. That's going to include, for those of you who may not be aware, a very, 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 very brief description of what software containers are. I'm sure many of you already know the bulk of software these days is written to run in a container in a Kubernetes cluster or maybe on a virtualized server somewhere. And there's a lot of benefits to why that is, and I'll talk about that. Then we'll talk about how Docker can help, number one, accelerate your onboarding for your project. In other words, how can you get coding faster with your project? How can Docker help with that? How can Docker enrich your development experience by allowing you to use extra tools that maybe you didn't think of or you might not have access to, or maybe you would normally be relying on a shared development environment for. Number three, maybe shifting your testing left to increase your confidence with how often you push code. And finally, securing your software. I wouldn't be a good steward of my company if I didn't have an eye towards corporate governance and the security folks who are going to be freaking out at some of the things I say to begin with. So I got to make sure I appease them. So any questions about what we're hoping to cover? Okay, cool. Due diligence, right? This is for my company. Just so you know, our vision has changed in the past 10 years. How many of you recognize the name Docker Swarm? A couple of you, right? So about 10 years ago, Docker got it into their heads that they would compete in the container orchestration space, along with companies like Mesos. Some of you might know that name. And Kubernetes basically ate everyone's lunch. So in 2019, Docker recapitalized and focused primarily on improving the developer experience. We do have several tools that improve your workflows throughout continuous integration pipelines. We have some things that still impact production, but we're really primarily focused on the inner loop, right? The developer experience, if you're familiar with that. To that end, I want to ask you guys a question. How many of you have played or do play a sport? An instrument? Have ever engaged in the creative arts, painting, pottery? Do yoga or meditate? Right? How many of you have, as a part of those activities, entered, ever been in the groove, right? And you might have heard that. I'm 54, so, right? Have you been in the groove? Have you ever entered that state where kind of time falls away and you're just in the moment, right? We call this a flow state. The flow state has been studied heavily over the past 50 years across sports, across arts. You can Google developer productivity flow state and you'll get about 100 articles on it. The long and short of that story is people who are in a flow state can be up to 500% more productive than those not in a flow state. This is a 10-year study done by the McKinsey Group and Harvard Business Review. So I didn't pull it out of a developer rag, right? This is somebody else entirely doing this research. It begs the question then, why am I talking about it and how does Docker help you? Well, the reason why I'm talking about it is this is kind of how I think about enabling developer productivity. Because at the end, at its core, even though I'm not a developer by training or trade, in fact, I'm a theater kid and a singer by training and education, and I'm an infrastructure guy. I worked for VMware for 18 years. I do kind of consider development at its core, a creative endeavor, right? And so if we can enable a flow state and get you more productive, you're gonna have a better experience, you'll have a better time, you'll produce more software with greater confidence. So it's important for me to kind of understand what is this flow state thing. And at the end of the day, right, write that one down, that's a good one. The idea here is you have a task or a set of tasks, which are challenging, but you know you can accomplish. Number one. Number two, when you're working on this, you get immediate feedback, right? Think, I'm playing a soccer game, I'm playing volleyball, I'm playing an instrument, I'm on stage, whatever. You're getting immediate feedback. Either you make a mistake and you lose the ball or you score. That's immediate feedback. Secondarily, you have complete control in the moment to make the decisions necessary to accomplish your goal. And this is the one that security guys freak out about, right? As developers, I know that my developer colleagues at Docker like to have access to the tools they want to have access to so they can develop their task, right? They can finish their task, which isn't always looked kindly on by the people in corporate governance. Like, what do you mean you want to download that? Has it been through the security review? Have you answered the questionnaire? Have we done our testing on it? Is it in our portal? Is it configured with SSO? Are you entitled to it? No, but I want to use it, right? So, but you have the ability to make the decisions you need in the moment to accomplish their task. Number three, you have no fear of making mistakes, right? Making mistakes and getting judged for those mistakes is obviously a bad thing for productivity. And finally, you have no awareness of distractions. As humans, we are terrible multitaskers. Anyone want to guess how long it takes to get back on task if you've been interrupted? 20. Okay, you've done your reading. It's about 20 minutes, about 20 to 23 minutes. You get in, if you're in the moment and you're working on somebody and someone says, hey mom, hey dad, can you come fix this for me? It takes at least 20 minutes to refocus on that task. So distractions are bad. If we meet all of these conditions and you're in the moment, you're making decisions, you start to experience this distorted sense of time, time falls away, and you start to get this intrinsic reward. Scientists think it's kind of like this really fancy dopamine feedback loop, right? Where you're working on something, you get rewarded, you're making decisions, you get more rewarded, you get more invested, you get more rewarded, and this is why we get more and more productive. So how can we view the act of software development in this light? How can we help you? I broke it down, like if we think about this slide, there's some things we can control as an outside party and some things we can't, right? I can't control your corporate culture. I can't control who your boss is and if they're a micromanager or not. But I can help with some things. I can help with tooling, right? So how can tooling help you? Number one, we want to remove distractions. What are distractions in software development? I think of this in terms of dependencies. Right? Do you have to use a shared development environment? Do you have to get access to that development environment? Do you need credentials to access the shared development environment in Amazon? And have you been onboarded yet? Has somebody opened the Jira ticket and responded to the Jira ticket so you can get access to the credentials and so on and so on and so on, right? To the extent possible, we want to remove as much as that as we can. Because if we can remove some of those dependencies, then you can get to work faster. Number two, autonomy and control. This is all about having a richer experience. This is one of the things we're going to see, hopefully, in the demo, assuming I get to it in time. Being able to use the tooling that you want to as a part of building your project. And sometimes that means using tools that maybe you wouldn't normally have access to. We'll talk through that. Number three, faster feedback. The quicker you can get feedback on your project, the quicker you can troubleshoot the code that you're writing, then the more confidence you have pushing code into your pipelines. And of course, as I said, we want to do it all with an eye on security, but in a way that does not intrude upon your workflow. Hopefully, we'll see how that works as well. So, let's talk about this. In terms of context then, what is a software container? I think about a software container like a smartphone app. When you go to install a new app on your phone, is there anybody here who doesn't have a smartphone? Great, right? So you either have access to the Apple Store or the Android Store or the Google Play Store or whatever it is. I'm an iPhone guy myself. You want to install a new application, you just go to the store and you say, hey, get me this application. What do you not think about? You don't think about security. Do you think about configuring the application? Do you think about environment variables for the application? Or configuring an ini file or a JSON file somewhere to control its behavior? Do you think about installing extra libraries that application is going to need? No, right? That app brings with it all of its dependencies. It brings with it its configuration. Sometimes it even brings with it a base set of data. All you got to do is hit open app. You're off and running. Software containers are a lot like this. How many of you have heard of the, well, it works on my machine joke, right? How many of you build with containers on your laptop or your workstation today? Oh, interesting. Everybody's used Docker, but not many of you actually use it. Okay, all right. Challenge accepted. All right, so I know what my job is. The idea here is if you can build with containers from the beginning of the software development lifecycle, you are not necessarily 100%, but much more guaranteed that if it works that way on your laptop, it's a container. It's got all the packages, libraries, configuration, sometimes even data that it needs to work over there, wherever over there is. AKS, EKS, Kubernetes, and your private enterprise, whatever, right? Couple terms you're going to want to know. A container actually refers to a process that is running, right? So it's consuming CPU cycles and memory. An image is how we package a container, right? So, it's a document for all intents and purposes. It's a file that contains all of the binaries and executables and configuration data necessary to execute the container, but it's a standardized format. Where do we store an image? We store an image in an image repository, which you might know as a registry. Anybody know what Docker's registry is? Docker Hub. How many of you have heard of Docker Hub? Okay, so a few of you have heard of Docker Hub. Docker Hub is the largest public registry of container images in the world. There's over 700 million downloads daily. Public. Lots of corporations have their own private registry as well. It might be on Artifactory, it might be on GitLab, it might be on your GitHub Enterprise, it might be in Amazon, it might be in Azure, but you can also get stuff off of Docker. The great thing about this is Docker Hub provides this enormous library of open source software that is provided as a container. You name it, it's probably been containerized, and you can probably find it on Hub. Why is that important? Because everyone gets this really, really, really big chest of Legos to start with. And your code and your decisions make the determination on what it turns into. I built this guy last year. I've now got the yellow McLaren. If anyone's into Legos, I like Technic sets. But your code and your artistry and your decisions are going to decide what turns that big bucket of open source building blocks into flowers or cat or Millennium Falcon or what have you. How many of you have ever had to install Postgres or Redis or MySQL on your workstation for a project? Have you ever had to install more than one version? That's fun, right? Do you uninstall the old one? Do you create a whole new repository and then somehow try to cordon it off? You could just use containers. So this is Docker Desktop. This is installed on my MacBook. I have a seamless connection to Docker Hub. I can just do a search on Postgres. And by the way, here's Postgres. You can see there's lots of options here, but if you look at the one with the little green icon, that is the Docker official image. That means Docker is responsible for hardening it, maintaining it, updating it, etc. If I click on that, you can see I've got lots of different versions I can download. 17.4, 16.8, 14.17, 13.20, etc. And down below, there's a whole bunch of instructions on how to run it. So let's do it. I've already got the command prepped. Docker run. I have to give it an initial password and a port, and I want Postgres 17.2. Yes, allow. It's going to go out to Docker Hub. It's going to pull it, and it's going to run it. Now, how do I know it's running? Well, I want to connect to it, and as I've already got the command prepped, I have to give it the initial password, which I gave it, which was dev. And it tells me, hey, you're now running Postgres 17.2. I can run a query against this. Let me find my command for running a query. Where's my mouse? The mouse is over here. Copy. Paste. All right, whoops. I can run it. I can run a query against it. I can run more than one version. Now here, I'm pulling Postgres 16.6 and I'm running it on a different port. That easy. And again, I can attach to it, give it my password, and run a query against it. Now, how do I know that I'm actually running? I'm not like tricking you. If I go over to Docker Desktop and I look at my containers, you can see I've got Postgres 17.2 running and Postgres 16.6. I didn't install anything. I didn't worry about dependencies. I didn't worry about any configuration data. I just passed it seamlessly in line. Does that make sense? How many of you have done this before? Now, my hypothesis, my premise to you is if you can leverage these techniques as a part of building your own software on your workstation, if your company allows it, right, you will accelerate your development of your projects because there's a lot less you have to worry about locally. I can run 20 different versions of Postgres, never worry about conflicts, upkeep, maintenance. I want a new version, I just change the command. Okay, so first things first, let me get rid of these because I will have port conflicts if I don't. If I go over to my terminal, I'm just going to close this. Quit. Terminate. All right. Any questions about what I did there or why or how? All right. I did the demo. Yay me. So let's expand our example. These days, applications are built using microservices, which means you've got some code that's probably going to talk to a bunch of other things. Right? And in our example, I'm building a backend API service that updates product data in a database. That means I need to talk to Postgres. Well, we just saw I can use Postgres locally. I'm going to get information about the inventory, like how many we have in stock from a backend inventory service. I'm going to store product images in an S3 bucket. I'm going to stream messages about product updates over a Kafka streaming service so that other applications in my enterprise can track what's going on with the inventory database. Make sense? Does anyone have questions about this example? Okay. So how would I build this environment? Well, of course, I'm going to start with something like VS Code. And I'm going to have some JavaScript here as an example, which I can use for doing things like, connecting to a database, getting a client from the database, inserting rows into the database, right? So here I'm pulling information out of the database. I'm inserting information into the database. Obviously, this requires a database to communicate to. What about the rest of it? Well, we already know I can run Postgres as a container. Kafka, I can run as a container. I can do a Docker pull Kafka. Local stack. How many of you are familiar with local stack? LocalStack is a third-party company, and they create a container that you can run locally that emulates all of the Amazon APIs. So I don't need an account or a VPC or an anything in Amazon. I can emulate everything in Amazon locally. Lambda, EC2, S3, etc. Right? What about external services? Well, you can mock up APIs all day long using a product like WireMock. WireMock is a simple application that runs in a container. You put together a short JSON file that says, here are my expected API responses. You run it, and suddenly you're talking to your API. Now you'll notice a couple other things that I've got over here. pgadmin is an admin interface for Postgres. Why might I want that? Well, I might want to make sure my data is getting inserted into the database correctly, and I might want to visualize that, right? Kafbat, similarly, is a visualization tool for Kafka messages, so I can make sure that the messages that I'm streaming out from my application are getting formed correctly. So I'm coding here, but this is the rest of my application, and if I want to be able to develop against it and troubleshoot it fully, I either need this running somewhere else, I'm going to run it all as containers. So how easy is that? Well, if I have Docker installed and I have my Visual Studio extension for Docker installed, one thing I can do is I can put together something called a compose file. Docker compose is a text file in YAML format that just defines what your containers are. So for example, here's a Postgres container. I define my username and password and the name of the database. I'm also defining pgadmin, which is the visualization tool for Postgres. Down here, I'm defining my local stack container, which says I want to create an S3 bucket. And then down here, I have WireMock for my API service, and then finally, Kafka. Do I expect you to come out of this knowing exactly how to form a compose file? No. What I want you to walk away with is this. Compose up. It's going to go out to Hub, pull all those containers down for me, configure them in conformance with my compose file. I now have WireMock, Kafka, local stack, Node, Postgres, and pgadmin running. I have my entire environment for my application running. Now I need to run my app. Now, my app is not yet containerized. So I'm going to go to a terminal, and I'm just going to say npm run dev. My server is now listening on port 3000, so I can come over here. I've got these bookmarked, of course, to make it easy for me. Here's my application. I can create a product. I can get the image. We can do two. Okay, my application's working. Fantastic. Anyone have questions about this? How do I know this is actually running? Well, let's go to pgadmin, and I'll show you the database. I'm running against my local host with a password of Postgres. I'm just going to go down to my catalog database, look at my table. Look, right, there we are. Two products, new product, UPC 1, UPC 2. Now, somebody has opened up an issue and said, hey, as a consumer of Kafka events, I would like to have the UPC code added to the product created event. This is what I expect to see. All right, this tells me several things. Either I've done something wrong with the Kafka streaming messages, or they're not receiving them correctly. So I need to validate this issue. I need to update the code, and then I need to test the code to make sure it's all running correctly. So first thing I'm going to do, we talked about Kafka earlier. I'm going to say, oh no, Kafka isn't running. Well, let's go check my compose file. Here's Kafka, and sure enough, There's nothing in here for Kafka visualization service. Okay, so what I'm going to do here, open up a quick terminal, and I'll say Docker AI. How can I add a Kafka? You can see I've already asked this question before, right? How can I add Kafka visualization to my product? So yes, like everyone else, we're into the Gen AI thing. This is a chatbot expressly for Docker work streams, right? So you're not going to use this like Copilot and go ask, hey, Stack Overflow, show me this error, whatever, right? This is specifically for enhancing your workflows around Docker. So gave me a message, all right? Hey, you can use the Kafbat UI web application, and it tells me a whole bunch about it, but the best part is update your compose file with this, all right? So I'm literally just gonna take this. Oh, I guess I have to click and drag. Copy it. And at the end of my file here, paste it. I need to fix the indentation. All right, it's indented correctly because Visual Studio is giving me this little signal that it's ready to run the service. So I'm going to save it. First, I'm going to do a compose down to shut down everything. I'm also going to go to my Node app and kill it. Oops. Then I'm going to do a compose up again. And Kafka UI is in there. That's good. There's my Node app. Here it is. And I'm going to do an npm run dev again. All right, now I'm in my browser. First of all, let me refresh this, create a product. Okay, I got one, I'll do 1, 2, 3, 4. So we know we've got at least 4 UPC codes I should see. I'm going to have to close this and reopen it again. So let's go to pgadmin. Down to my schema, look at my tables. Okay, so first thing I know is creating the products correctly, and I am creating UPC codes, and UPC codes are in the database. So now we go back to my original task, which is validate if those are actually coming out in my Kafka streaming messages. And all right, so Kafka is running. I go to my topics, look at my products and my messages. No UPC code. Okay, so the Jira ticket was written correctly. I am not providing UPC codes in my streaming messages. I know how to fix it though. So I'm going to come over here to this. You can ask me a question. Here it is. No, that's not it. It's up here. Add my product UPC code. I do have hot module reload. You may have noticed that my app automatically restarted. So all I need to do now is come back over here, create a new product. It should have a UPC code 5. I double check my database. Yes, I do have a UPC code 5. I update the messages in Kafbat. I do have a UPC code 5, but my older messages no longer have it. Does this make sense? I did that 10, 15 minutes. How long would that take you if you were relying on corporate infrastructure?
You have 2 things installed.
What's that?
You have 2 things installed, maybe.
Maybe you'd have 2 things installed and everything else you'd be waiting on. What if this was an integration test and the pipeline failed because Kafka message wasn't updated correctly? How long would that take to get back to you and for you to fix it? It's not a rhetorical question. I'm genuinely curious. How long do you think it would take you to fix it, given your own specific circumstance? An hour? A week? I work with some really big corporations that say, yeah, it might be 30 days. Because, you know, once it fails in pipeline, it's just a JIRA ticket, and they're working through a backlog of 300 JIRA tickets. Does that sound familiar to anyone?
Yeah.
Okay. So I've validated it. I've updated my code. We know it's working. I got to update my tests now. So yes, we did that. Awesome. How can we now improve your confidence in your testing process, right? Writing tests, unit tests, component tests, integration tests, it's all about improving not just the code you write, but improving the confidence that you have that it's actually going to make it through the pipeline. Testing pyramid, yes, everyone knows what the testing pyramid is, right? The ideal, lots of unit tests, some integration tests, a few end-to-end tests. However, I was one of those guys in infrastructure that's like, yeah, no, I'm going to build your infrastructure for you. Don't worry, man. We got it. But I need to update my version of JBoss. Has it been through security? No, we can get to that next year. Continue with whatever your current version is, right? Building infrastructure for integration testing is hard. I did this with a lot of customers at VMware, and rough and tough, there's usually about 10 times the amount of infrastructure dedicated to dev, test, and QA than there is to production. If I need a cluster of 5 servers for prod, I probably have at least 3 clusters of 5 servers for dev, test, and QA, if not more, because we might be running multiple different versions. I worked with this one customer down in North Carolina. They hold on to and maintain every version of software that their customers have ever run for the past 40 years. Let me tell you how big their storage arrays are, like just enormous, right? So we end up seeing a lot of this kind of thing where integration testing is compressed just because it's hard to do. And these days, with the rise of microservices, the emphasis on integration testing is even greater, simply because of what we're doing in here today. Yeah, my app is simple. It's like 50 lines of code, but I'm talking to 6 other things. So for me to make sure my app works, I got to talk to 6 other things, right? There's nothing but integration testing, really, right? My unit tests are, is that a digit? Yes. It's a digit. Okay, send it to Kafka, right? The integration testing is where it's at. So, enter test containers. How many of you have heard of test containers? Anyone? All right. About 10 years ago, after Docker first incorporated as a company, some very, very clever people out there created an open source library called test containers that handles programmatic orchestration of lightweight containers for testing. What does that mean? I'll show you. The idea here is, now I've shown you the compose file, and this is unique and specific to Docker. Could you learn it? Yeah, it's not terribly hard. But that's a distraction, right? That's talking about one of those things we want to get rid of. Wouldn't it be great if you could just do it all in code? Well, I have an integration test here, and this is the scaffolding for my testing framework. And the very first things I'm doing here, no. The very first things I'm doing here is I'm defining some constants. I have a constant for a Postgres container, where I'm going out and grabbing the Postgres module from the test containers library. And then the same for Kafka and the same for local stack. And whereas previously I was configuring these containers in my compose file, I'm doing it in code down here. I set my username and password for Postgres. Down here, I set my Amazon region and username and secret code, etc., for my S3 buckets, and so on. Now, why is it important for me to be able to do this in testing? Well, if I have a lot of tests and I'm managing it all with compose, I'm going to do a compose up, run a test, oh, that broke, compose down, fix. Compose up, run a test, oh, that broke, compose down, fix. I want to run through my entire test suite. And I want to do it quickly and often, because that's why test frameworks exist, right? So by defining it in my code, I don't have to worry about my compose file and doing compose up and compose down, right? So let me just make sure compose is, I've already shut everything down. Where's my compose file? There we go. Shut things down, compose down. And I'm also going to kill my node application so that you know that I'm not actually running it any longer. Right, so here's my containers and everything's gone, right? My catalog tool set is gone. I have a test right here, right? Let's go down to line 70, right? I should publish a Kafka message, and we know now that I need a UPC code with it. So I want to add the UPC code. Created product.upc, right? I've now added that, and I want to run this test. What you're going to see is a whole bunch of stuff here from test containers, right? It's pulling a whole bunch of stuff. But what you should see over here is I'm pulling containers, spinning them up, configuring them, and tearing them down automatically. I don't have to do this. As a matter of fact, if I wanted to do the entire, let's see, okay, it passed. I only did one test of the suite, so let's actually go to my testing suite and let's run everything. And just so you can see it happening, what you're going to see here is a whole bunch of containers spinning up, right? There's Postgres, there's Kafka, there's local stack. And when it's done with the test, it tears them all down. The great thing about this is if I get this working correctly on my machine, guess what's going to work flawlessly in pipeline? The tests that I write here, but I'm leveraging test containers, they're just going to execute exactly the same way in my pipeline. And I don't have to worry about things getting stuck because test containers are just going to tear it down. I don't have to worry about resource contention because if I'm using the cloud version, that one's paid. If I'm using the cloud version, that'll scale automatically. So it'll scale to demand, right? Okay. So when I say programmatic orchestration of lightweight containers for real dependency testing, that's what I'm talking about. I configure a few variables or constants in my test framework. I configure them. Now my test suite can do whatever it needs to. There are modules for just about anything you can think of. So if you're coding in Python, yeah, you can pull a Python. You can pull a Postgres container for Python in your test code using PyUnit or whatever, PyTest. If you're using Redis and Java, yes. .NET, yes, and so on and so on. We did that, yay. Okay, finally, hey, I'm almost on time. Look at this, I'm almost on time. How are we going to do this all at reduced risk? There's a lot of questions that come up when using open source software, right? The trick with open source software is you never know when a new vulnerability is going to be discovered. Does anybody here remember Spectre and Meltdown? This is what, 2019 was it? 2018, 2019? I think it was winter of 2018 to 2019 when suddenly the whole world recognized that somehow a fatal flaw was available in the Linux kernel and had been there for 20 years. Look it up. Spectre and Meltdown, Intel Spectre and Meltdown. It was a terrible, terrible flaw. Entire data centers had to get shut down for months at a time to completely retrofit chips, BIOS, kernels, etc. So, are we using a Linux-based image? Is it from a trusted source, right? Are there any high-profile vulnerabilities? Are there fixable vulnerabilities? None of us want to think about this, right? But we might need to address it. And so the goal is how do we keep it, how do we address it as easily as possible, right? Can we do it at the source? Yes. Can it support the entire pipeline to production? Yes. I'm going to show you just the simplest example here. Included with Docker for the past 2 years is something called Docker Scout. Let me go back to my code and my terminal. Docker Scout. Once you have an image, all you have to do is run Docker Scout Quick View. Now, this is a copy of my image. I've built my application into an image. I've called it Catalog Demo. So just for kicks and grins, I will run it again. Docker Scout Quick View. What it's going to do is it's going to go out, index what's in my image, including all of the packages and libraries installed. It's going to compare that against over 20 known published databases of vulnerabilities that have been identified. And it's going to tell me you've got 13 high, 7 medium, and 132 low vulnerabilities. That's not great. That's like maybe a C or a D rating. Right? The only thing that would make it an F was if there were critical vulnerabilities. Furthermore, we can see that some of those are fixable. So you better know that if I submit this into my pipeline and there are fixable high or medium vulnerabilities, security is going to say fail, ticket. It's going to end up back in my queue. So how can I fix it? Well, I'm just going to say, give me recommendations. And you'll notice we give you hints. Hey, do one of these next. Right? So I'm just going to copy and paste. Back up to the top. And it says, okay, you're using the Node 18 image. The latest is Node 23 Slim, which has no high, no medium, and only 23 low. So that's an improvement of 8 critical, 8 high we got rid of, 6 mediums we got rid of, and we got rid of 105 low ones. How do I update that? Super easy. I'm going to open my Docker file, and again, this is not something you necessarily need to know right now, just the art of what's possible. I'm going to change from using Node 18 to Node 23. I save that. Let me close all this. Close, close, close. Close. Now I do need to build my image again. So I'll call this version 2. Going to go out and get the latest node image, which instead of 18 is 23. It's going to export that to an image. Now I'm going to say Docker Scout. And I'm just going to jump right to recommendations, except I can't spell. And it's catalog demo v2. And in less than 5 minutes, I have taken my riddled with vulnerabilities image, and I've taken it down to only 23 low. My security team is going to be way happier, right? That did not require a tremendous amount of extra learning. It was not a huge distraction for me. I'm already using a bunch of Docker commands. That might be a little bit of a learning curve for you, but I submit the benefit of learning a little bit of Docker, enabling you to do what I just did here today, could dramatically change your development experience. Okay, back on. Yes, we did that. I don't need my dictionary. Well, real quick recap. So what did we talk about? Number one, faster onboarding, right? The ability to add services to your environment instead of having to install and maintain them separately. Number two, using real services and added tooling for your project to expand your scope and enhance your ability to troubleshoot and get work done. Consistency, consistency, consistency. If it runs here, It's gonna run there. My integration tests, I'm running them here. I know they're gonna run there. And integrations all over the place. Docker has probably the broadest set of integrations beyond any other behemoth besides something like Microsoft. And we saw this all with real tooling. Now, I didn't put the I'm not using IntelliJ, I'm using VS Code, but you get the idea, right? And all of it, enterprise ready, access and management to what you can and can't do, so your security teams can provide guardrails. We didn't talk about that a lot today, but that is something that is available. To get you faster onboarding, a richer experience, improved confidence, and reduced risk, all as a result of Flow. If you enjoyed today, please answer the survey. If you want access to the repo I used, that's the QR code for that. What kind of questions you guys have? 301. What kind of questions you guys have? Anything? Awesome. Yeah.
Oh, but I throw maybe a hardball one out at first.
Yeah.
In the last couple of years, I've noticed there's been some controversy with like the open source community as Docker has kind of changed some of the rules around Docker Hub.
Yeah.
I was wondering if you could speak to like what I guess the relationship is right now and like
The monetization strategy.
yeah, well, I guess like can we trust that like open source projects will still be available and runnable through Docker, or is that something we need to be concerned about?
No.
Okay.
So we just hired a new CEO,
Okay.
a fellow by the name of Don Johnson. Not that Don Johnson, not Miami Vice Don Johnson. Don Johnson actually was the lead software developer back in 2010 on EC2.
Okay.
And then he was the lead the team engineering lead on Oracle Cloud. And so he joined us about a month ago, and his perspective is give the candy away, guys. Like, give the candy away, right? So for those of you who aren't aware, we made some noise in the industry. First of all, 2019, we recapitalized. If you work for a corporation and you are using Docker Desktop as a part of your business, there is a licensing, right? So there is a license, right, that you might be exposed. You might have to pay for a license to use Docker Desktop for your business. There are lots of benefits to doing so because aside from what I showed here, there's a whole portfolio of stuff you can get access to as part of a paid plan. However, in addition to that, we also talked about monetizing Docker Hub and a few other things. And Don Johnson came in basically and said, you're not supporting the open source community. We're going to be doing other things that we monetize. Docker Desktop will remain free and available for individual users. Docker Hub will remain free and available for open source utilization, so you have no concerns there. Yeah, because there was a little bit of a crazy Ivan that we pulled last year, and all of us too, we were like, really? They corrected that.
Okay, I appreciate it.
Yep. Anything else? Thank you very much and enjoy the rest of your day.